Greetings to my dear students. So we are learning evaluation of integral using Cauchy's theorem and Cauchy's integral formula. So in this video, we are going to evaluate the integral value of e power z by z square plus 4 dz, where c is the circle, modulus of z minus I is equal to 2. Okay. So the given integral as e power z by z square plus 4. Okay. So here, as in the last problem we had seen, the denominator part is not in the form z minus z naught. Okay. So instead of this, we have z square plus 4, a quadratic equation, So we have to convert this quadratic into linear equations. So for that, what we have to do, we do the partial fraction. Okay. So we consider this function e power z by z square plus 4, and we do the partial fraction and split it into two linear fractions. Okay. So e power z by z square plus 4 is equal to e power z by z square plus 4. How we can rewrite this? We know z square if minus 4. Okay, how we will rewrite this? Z minus 2 into z plus 2, isn't it? Z square minus 4 can be written as z minus 2 into z plus 2. Okay, so instead of minus 4, here we have plus 4. Okay, so plus 4 means what will happen? Z square plus 4. So we consider this is equal to 0. Okay, we clear everything. Z square plus 4, it is equal to 0. So therefore, z square is equal to minus 4. So that z is equal to plus or minus square root of minus 4. So square root of minus I is equal to the value of square root of square root of minus 1 is equal to I. So plus or minus I into square root of 4. Because this can be written as square root of minus 4 can be written as square root of minus 1 square root of minus 1 into square root of 4. So square root of minus 1, the value of square root of minus 1 is I, square root of 4. Square root of 4 is what? 2. So we have z is equal to plus or minus 2i. So the one value is plus 2i and another value is minus 2i. So therefore z square plus 4 rewrite as z plus 2i into z minus 2i. So next we apply the partial fraction. So e power z by z square z plus 2i into z minus 2i can be written as some a by z plus 2i and some b by z minus 2i, because they have it's a linear equation of degree 1. Okay. So this is the method to write the e power z by z plus 2i and z minus 2i into partial fraction. So what to say? This is a general theory. We have to we have to move by this only. We cannot apply some a z plus b here, some b c z plus d here. We cannot done that. We have to, if it is of degree 1, then we have to split this into some a by z plus 2y and some b by z minus 2y. Okay, so now we are taking the LCM. So it is equal to a into z minus 2y plus b into z plus 2y divided by z plus 2y into z minus 2y. Now these two will get cancelled. So the remaining we will get as e power z is equal to a into z minus 2i plus b into z plus 2y. So next our aim is to find the value of a and b. In order to find the value of A, we have to omit B. So how we can omit B? If we substitute Z as minus 2i, okay, if we substitute Z as minus 2i plus 2i will become 0. So B will vanish. Okay, in order to find the value of B, we have to vanish, we have to omit this part. So how we can omit this part? If we substitute 2i in the place of Z, this will become 0 and this part will omit. So we get the value of B. Okay. So if we substitute Z equal to 2i, A will vanish and we get the value of B. If we substitute Z equal to minus 2i, B will vanish and we get the value of A. Okay. So when we substitute Z equal to 2i, what will happen? Here E power Z we have E power Z. So this will become E power 2i is equal to A will vanish. The remaining thing is we have B into 2i plus 2i 4i. So therefore B is equal to E power 2i by 4i. When we substitute Z equal to minus 2i, B will vanish. So we get E power minus 2i is equal to A into minus 4i. Therefore, A is equal to E power minus 2i by 4i. So we found the value of A and B, and we are going to substitute the value of A and B in this equation. In which equation? In this equation. This equation. Okay. E power Z by Z square plus 4 is equal to A by Z plus 2i plus B by Z minus 2i. In this place, we are substitute the value of A and B. Okay. Okay. So therefore, E power Z by Z square plus 4 is equal to the value of A is E power minus 2i by minus 4i divided by Z plus 2i, and the value of B is E power 2i by 4i divided by Z minus 2i. So next, what we have to do? We have to take integral on both sides. So therefore, integral over C E power Z by Z square plus 4 dz is equal to integral over C E power minus 2i by minus 4i by Z plus 2i dz plus this one and this one. Okay. So here E power minus 2i by 4i is a constant term. So we are taking outside. Similarly, E power 2i by 4i is a constant term. We are taking outside. So therefore, integral over C will become this. So now we evaluate the integral this separately and the integral this separately, and we multiply by this and multiply by this one. Okay. So yeah. So first we find the integral. Okay, first we consider the integral this one. Okay. So here, what is the value of f of z? When we compare this equation with the Cauchy's integral formula, we get f of z is equal to 1. Okay. At which point the analytic fails? Minus 2i. So next what we need to do? We have to check the point minus 2i lies inside or outside. Okay. So for that, what we have to do? So what is our circle? Modulus of Z minus I is equal to 2. Okay, so this is our circle. Modulus of Z minus I equal to 2. Modulus of Z minus I is equal to 2. Okay, so here in this place Z, we have to substitute the value minus 2i. So minus 2i minus I, which is equal to modulus of minus 3i. Modulus of minus 3i is equal to 3, which is greater than 2. Okay, which is greater than 2, which means it shows that the point minus 2i lies outside the circle. Okay, it is greater than the radius. So therefore, this point lies outside the circle. So inside the circle, the function is analytic at all points. Okay, the function is analytic at all points. The point in where the point at which an analytic fails lies outside the circle. So it going to give any trouble to the function f of z since it lies outside the circle. So therefore, by Cauchy's theorem, okay, by Cauchy's theorem, the integral value is 0. Integral value is 0. Okay, are you able to follow? Because the point uh, where the analytic fails lies outside the circle, but we are taking the integral over c. Okay, we are taking the integral over c, integral over the circle. If the point lies outside means we don't need to bother that point, isn't it? So but inside at all points in the all points inside the circle, the function is analytic. So therefore by Cauchy's theorem, the integral value is 0. Okay, so first integral will become 0. So consider the second integral 1 by this one. So here, what is the value of f of z? F of z is equal to 1. The next, we check the point 2i lies inside or outside. Okay, so as our circle is modulus of, sorry, yeah, as our circle modulus of z minus I equal to 2. Okay, so substitute the value 2i in the place of z, we get 2i minus I, which is equal to modulus of I is equal to 1, which is less than 2. Okay, which is less than 2. So this shows that the point 2i lies inside the circle. The point 2i lies inside the circle. So in this situation, which formula we have to use? Cauchy's integral formula, not Cauchy's theorem. Okay. So by Cauchy's integral formula, what we will get? Integral over c 1 by z plus 2i dz is equal to 2 pi I into f of 2i. But since f of z equal to 1, f of 2i is also equals to 1. So we get the integral value as 2 pi I. So now we found the integral value of this and this separately. Now we are going to add so that we will get the integral value of this one. So therefore integral value of this equal to e power minus 2i into integral value of this. But integral value of this is equal to 0. This part will become 0. Okay, this part will become 0. Plus e power 2i by 4i. What is the value of this one? 2 pi I. Okay, so therefore we get e power 2i by 4i into 2 pi I, 2i and 2i will get cancelled. So the answer is e power 2i pi divided by 2. So that is pi by 2 into e power 2i. So here we use both the Cauchy's theorem and Cauchy's integral formula. Okay, if the point lies outside means you can without thinking a second, you can directly put the value as 0. If the point lies inside the circle means you have to use Cauchy's integral formula. Okay, so I hope this problem is clear to you all. So we will see the remaining in the upcoming videos. Okay, thank you everyone.